I guarantee your mind will be changed after you see this video about the UK. Britain, the home of high-tech innovation, is where engineers built a tower's core from the top down and relocated an entire building's life support systems to the exterior.
On the Constructive Minds YouTube channel, we've compared the construction industries of many countries worldwide, like the US, China, Spain, Singapore, Dubai, and many others. We've traveled from east to west, from fair skin and blonde hair to almond eyes. We went to the desert and witnessed civilization. We delved into history and saw the masterpieces. We saw the structures that defied the rules.
The question is, which country, in your opinion, builds the wildest buildings? A country that erects structures, even within its historic fabric, that fundamentally challenge the experts.
We intend to unlock the hidden technical secrets behind these masterpieces, from managing dynamic wind loads in their tallest structure to the challenges of corrosion and thermal stresses in exposed steel connections.
Hello, I'm Eleanor, meaning shining light, and I'm here with my friend Theodore to take a deep dive into London and technically analyze its 3 most peculiar and innovative structures.
And I'm Theodore. We are with you from the Constructive Minds YouTube channel. This is where a team of engineering and architecture experts gather to reveal the secrets behind the world's urban masterpieces.
If you love strange structures, engineering analysis, and bold architecture,
then subscribe to our channel right now and hit that bell,
so you don't miss any of our exciting episodes.
When you think of London, you probably think history, right? Old buildings, famous landmarks. But it's also this incredible living laboratory for some of the wildest engineering ideas out there. So today, we're going to peel back the layers on 3 of its most audacious structures. Buildings that were literally built top down, turned inside out, and even unzipped like a jacket.
Let's kick things off with a thought. What if the most iconic buildings in a city weren't just, well, buildings? What if they were actually rebels? Acts of rebellion against the normal rules of engineering, against gravity, and maybe even against time itself.
Right in the middle of historic London, you'll find 3 of these rebels, and each one is this, beautifully weird solution to a problem that seemed impossible. A bold statement in steel and glass that just completely pushed the boundaries of what everyone thought could be done.
All right, first up, we've got the Shard. And this thing wasn't just a race to the sky. No, it was a race against the clock. It was all about speed.
Okay, so picture the challenge here. It was absolutely massive. How on earth do you build a super tall skyscraper and do it super fast on this tiny, really sensitive patch of ground? And to make it even harder, it's right next to a major train station with tube tunnels literally just meters away. The old way of building just wasn't gonna cut it.
So what did they do? The engineers came up with this totally revolutionary idea called top-down core construction. And I mean, this thing completely shredded the old rulebook for how you build skyscrapers in a crowded city. Why? Because it let them build in 2 directions at the same time.
So think of it like this 3-part race happening all at once. You've got crews digging the foundations deep underground. At the exact same time, the central concrete core, the building's spine, is already climbing up into the sky. And then, and this is the really wild part, they started building the steel floors from the top down. It's completely counterintuitive, but it saved a staggering amount of time.
And that wasn't the only problem they had to solve. The foundation, for example, had to go 60 meters deep just to avoid messing with the train tunnels below. And you see that jagged shape? That's not just for show. It's actually aerodynamic. It breaks up the wind so the tower doesn't sway. And way up at the top, they've got these huge dampers, which are basically giant shock absorbers to make sure the people inside don't feel a thing.
Okay, let's move on to our next rebel, the Lloyd's building. Now this one also had a battle with time, but in a totally different way. It wasn't about building fast, it was about building something that could last.
So the big question for the architects was, how do you design a building that can change and adapt for a whole century? I mean, how do you repair it and upgrade it without ever having to shut the whole thing down? Basically, how do you future-proof a building?
Well, their answer was so out there, so radical that the building got a nickname, the Inside Out Building. And that's literally what they did. They took all the messy stuff, the elevators, the pipes, the air ducts, the building's guts, and slapped them right on the outside for the whole world to see.
And the logic, when you think about it, is kind of brilliant. If everything's on the outside, you can get to it easily.
Need to fix a pipe or upgrade an elevator? No problem. You don't have to shut down the offices inside. It's designed for the long haul. But there's a big but. You now have to protect all that exposed stuff from the weather, and that gets expensive.
Yeah, putting the building's skeleton on the outside created a whole new headache for the engineers. Suddenly, every single pipe and steel beam needed special coatings to stop them from rusting in London's damp air. They had to figure out these complex expansion joints because the pipes actually grow and shrink with the temperature changes. And every single connection had to be tough enough to handle decades of wind and vibrations without developing tiny, dangerous cracks.
All right, for our final marvel, we're looking at something that was only temporary but had a huge impact, the 2016 Serpentine Pavilion. And this thing didn't just question how you build something, it questioned what a wall even is.
The designers, a group called BIG, started with a really simple question. What if you could take a solid, straight wall and make it flow like a liquid? And their answer was to imagine taking a simple brick wall and literally unzipping it down the middle, pulling the two halves apart to create this amazing cave-like space inside.
The whole thing was made from just 681 hollow blocks. Now that number might seem random, but it's everything, because each one of those blocks was a unique piece in an incredibly complex puzzle, and these were not your average bricks.
Right, forget bricks. These were actually feather-light blocks made of fiberglass. And get this, each one had a totally unique shape designed by a computer program. They just locked together, kind of like super high-tech Legos, with no messy mortar. And that's the secret. That's how a solid, strong structure could look like it was melting into this beautiful, flowing arch.
So, when you put it all together, what do these three incredibly different, you could say weird, buildings actually tell us about where engineering is headed? What's the big takeaway from a skyscraper built downwards, a building turned inside out, and a wall that unzips?
Well, each one gives us a really powerful lesson for the future. The Shard, it's all about mastering the art of the possible, making things happen in really tough urban spots. The Lloyd's building, that forces us to think way beyond day one, to design for a building's entire life. And the Serpentine Pavilion, that's a shout out to embrace wild new materials and digital design. And the legacy of these projects is just huge. They've pushed the whole industry forward. We're talking about better ways to plan costs over decades, the rise of digital modeling, what we call BIM, and getting people excited about using lightweight materials and building things off-site. They really prove that these crazy-sounding ideas can lead to real, practical progress.
And all this leaves us with one last big thought to chew on. These marvels prove that sometimes the most genius solutions come from looking at the most basic rules of how things are built and just saying why. So if a wall can be unzipped and a building can be turned inside out, what's the next engineering rule that's just waiting to be broken?
It's truly incredible. We saw how London's engineers, by building the Shard, overcame the constraints of dense urban construction using the top-down core technique.
And of course, we mustn't forget the radical masterpiece that is the Lloyd's building,
where the technical challenge shifts from earthquake resistance to the management of corrosion and thermal stresses in exposed steel elements. That is the intellectual depth behind high-tech architecture.
And how thrilling was the analysis of the temporary Serpentine Pavilion. We saw how, even in a temporary structure, the use of GFRP composites and computational geometry engineering transforms the phenomenon of buckling into a new challenge for engineers.
In essence, these three structures prove to us that the UK's construction industry, through its fusion of tradition and radical innovation, has a lot to say against the megastructures of the US or Asia.
Do you remember when we asked you at the beginning of the video which country builds the wildest buildings? Now that you know the technical secrets of the Shard, Lloyd's, and Serpentine, we'd love for you to share your opinion in the comments section.
And if you are interested in a deep understanding of these kinds of structural engineering and architectural challenges,
this content was produced by the Constructive Minds YouTube channel. If you are interested in deep and engaging videos on construction and structures, subscribe to our channel.
Hit the bell icon so you don't miss the next video. And if you found this video useful, share it with your engineer, architect, or construction enthusiast friends.
Until another technical analysis, goodbye.